Hello, and welcome to this episode. We're going to talk about slopes and actually tangent lines. This is a very big topic, so we're going to just scratch the surface. First, we're going to talk about just the concept of what we're talking about for slopes and also the tangent lines. We're going to try to show how to find a slope at a point, and in the process, we'll also find the tangent line. We'll do an example, and then we'll compare how the tangent line and the original function actually are very similar and very close together near the point. So first off, suppose the red is a function. It curves, it goes up and down. It doesn't have a slope anywhere. It curves. It goes up and down and up and down. How can there be a slope? But if you look at it, any given spot, you could put your hand. There is a slope at a point. It's different at each point, but at any given point, there is a slope. So let's zoom in. The blue is the tangent line right at that point. So if you imagine, right when you're curving there, a tangent line just touches along the same speed as the function's going right there. So let's zoom in. If you zoomed in on that picture several times, look at that. The red, still, it has a tiny bit of curve in there, but not much. The blue is, of course, the straight line that has that same right there. Now the green, let's talk about the green in a second. But imagine, I zoom in again and again and again. The red is going to get straighter and straighter. This is called local linearity. And the idea here is that any function that is decent, and we won't worry about what decent means right now, basically any nice function, if you zoom in at almost any point there, you're going to have essentially a straight line. Not completely, but essentially. And that straight line, if you extend it forever, is the tangent line. That's what we're going to look for, because the tangent line has a slope. Now how do you find that slope? This blue line has a slope right at that point. What you do is you make do with what you have. You take another point on the red function. Red function, this is the thing we know. So we take any point on there. The point at the start we're looking at is a f of a. Any other point, we'll call it x f of x. So if we're close, that's almost straight. We'll call that the secant line. If you notice, tangent line, secant line, these come from trigonometry, and there's a reason for that. But for now, what we're going to notice is, if x is really close to the a, the secant line is really close to the tangent line. They're almost the same thing. So what we're going to do is, we're going to say, the tangent line is the limit of the secant lines as x gets close to a. Now, x approaching a is sort of a generic, and it works. But often, people, instead of using x, they're going to use a plus h, where h is something small. H is the distance away. So instead of saying this is x going to a, we're going to say this is a plus h, where h is disappearing. It's going to 0. So our 2 points, instead of a f of a and x f of x, are going to be a f of a and a plus h f of a plus h. And we're going to let h disappear, go to 0. So the tangent slope is the limit of the secant slopes as h goes to 0. So how do you find a slope? It's rise over run. Rise is the change in the y's, the change in the f functions, over the run, which is the change in the x's. There's a little bit of algebra here, not much, and you get to here, which is our basic formula. Don't pay attention to this right now. We'll come back to it. I just didn't have any other board space. So I want to do an actual example using this. In black here, my function is x squared plus 2. I'm choosing a is 1, so that means f of 1 is 3. So here's the function. Our a is 1 right here. And right there is our base point. And it's not perfectly drawn, but you can see the blue is the tangent line. How do we find the slope of that tangent line? Well, we take this limit. The tangent slope is the limit as h goes to 0. F of our a value plus h minus f of the a value over h. Now let's compute that. Put this 1 plus h in here. We get 1 plus h squared plus 2. All of that in parentheses. In this case, it won't really matter. Minus f of 1, which we already computed as 3. 1 plus h, square it. We get 1 By the way, that was a pause for you to work on, but you don't have to. Let's compute it. 1 plus there's middle terms, 2h plus h squared plus 2 minus 3. Now let's compute that. There's a 1 and a 2 added together. 1 plus 2 is 3 minus 3. Those all cancel. Now what's on top here? 2h plus h squared, and we're dividing by h. Well, we're dividing by h, we're not subtracting h, so factor out the top. Let me write that right over here. The limit as h goes to 0 of, factor the h out, 2 plus, how many h's are here? Well, there are h of them. And what can you do next? You can cancel the h's. Divide the top by h, divide the bottom by h. We have the limit as h goes to 0 of 2 plus h. And then as h goes to 0, it's 0. So we get a tangent slope of 2. So the tangent line is going to be y minus the y naught, the y base point. This is the point slope form. The y naught is there, equals the slope, 2 times x minus the x naught. Now if you simplify this, you're going to get y equals 2x minus 2 plus 3 is plus 1. Now take a look at that line compared to this blue. It's the same thing. This is the tangent line. But what's really interesting is what happens to the tangent line when you plug in a value that's not 1, when it's near 1. If I put 1.1 in here, I get 2.21. It's not that hard to compute this particular function. If I put 1.1 in here, I get, I'm sorry, I don't get 2, well, I get 3.21. Sorry. Because that wouldn't make sense. This is 3.2. Notice they're not the same, but they're close. The tangent line, when you're nearby, is very close to the original function. So if you have some ugly function that's really, really messy, but you can find its tangent line, you can plug values nearby and be pretty sure you're close to what the function is. So that was one of them. Now here's a messier example. I wanted to pause. I wanted to put this one on here to show you. But it's messier, and if it doesn't make sense, it takes more practice to get good at this. The function I'm using is 1 over x at a equals 2. So right here, we're looking at a graph like this. And the line is going to look like this. That's the tangent line. How do you do it? Well, here's that slope form. You take the limit of f of a plus h minus f of a over h. Now, f of x is 1 over x, so f of 2 plus h is 1 over 2 plus h. That's what you're going to have when you simplify this. Now, the thing is, that's fractions. You have to use common denominators, simplify, bring the bottom down to the bottom, cancel the h's. There's a lot of steps in here. That's the slope. I don't want to go through the whole process, but notice, that's a negative 1/4 slope. It's going to take some time before you master this, but hopefully it makes some sense, particularly for the easier functions. Until next time.